Hello everyone, my name is Dorijan and Radočaj. I will present a study titled Validation of Near-Surface Wind Speed Monthly Averages from CHELSA Climate Data in Croatia. First of all, why CHELSA dataset? CHELSA stands for Climatologies at High Resolution for the Earth's Land Surface Areas, and it is one of the very few 1 kilometer spatial resolution datasets which provide global climate matrices and averages. Their relationship is based on ground truth observations that determines the reliability of predictive mapping. So these are global data sets, and as such we cannot expect that they have the same local variability, the same accuracy across all areas in the world. So knowing how accurate these data sets are in our desired study area is very important for various predictive mapping studies, such as digital soil mapping, land cover mapping, habitat mapping, and so on. Moreover, validation ensures that these raster datasets accurately reflect such local variations and temporal trends. So within a year there are 12 months, so we can assess how representative are these datasets for all months across the year. And this shall be performed according to ground-based observations for Croatian Meteorological and Hydrological Service, DHMZ. Pretty much every country has a similar service like that, so this study is pretty easily replicable for any country in the world. Therefore, the study aim was to evaluate the accuracy of near-surface wind speed CHELSA monthly averages in Croatia. As I previously mentioned, this will be performed according to DHMZ climate stations, and Croatia is maybe a bit challenging country for such study, as it consists of 3 distinct biogeoregions: continental in the east, alpine in the center part, and Mediterranean in the western and the southern part. All these 3 biogeoregions have very distinct climate properties, as we will see later in the presentation. Observations on the effects of environmental conditions to climate accuracy can also be observed, as we will also see, and this is expected to provide guidance for future studies in this study area, but also for similar studies which also require similar validation of CHELSA or world climate data sets. There are 2 main input data sources. The first one is CHELSA version 2.1 monthly averages from the 1981 to 2010 period, as shown in this figure here, and 22 ground truth monthly averages from DHMZ climate stations from 1971 to 2000 period. And we can observe that both of these periods are 30-year periods, so they can represent long-term climate values, but CHELSA is 10 years newer. So this is a common issue, as the most recent official data sets were used, but country services usually lag such initiatives like CHELSA, World Climate, and so on. So this study has a minor limitation in terms of slight temporal discrepancy, as there is currently no available DHMZ data which is newer than the one used. CHELSA rasters were clipped to the study area, to Croatia, and they were projected to official Croatian projection in 1 kilometer spatial resolution. 3 statistical matrices were used for validation. The first one was the coefficient of determination, which was the relative metric for validation, and 2 absolute matrices, root mean square error and normalized root mean square error. Coefficient of determination and root mean square error are commonly used together in such studies, as they enable a full representation of the accuracy assessments, as we will also later see. So here is the main result, the accuracy assessment according to available ground truth DHMZ stations, and you can clearly observe a seasonal variability. So winter months such as January, February, and December achieved higher coefficient of determination in comparison to summer months, but the root mean square error is pretty much different from this. So these winter months resulted in much higher root mean square error than the summer months. So the coefficient of determination indicates that the winter months are more accurate, but the root mean square error indicates that the summer months were more accurate. So there is a clear seasonal variability pattern, and the disagreement in these statistical matrices could indicate either a consistent bias of near surface wind speed, so CHELSA values are consistently higher or lower than DHMZ data, or there might be a limited variability in these values. Moreover, the yearly averages of available DHMZ climate stations had a pretty high value range of 1.3 to 3.3 kilometers per hour, and this is pretty probable that this property distorted validation results. Additionally, few stations, primarily in the Alpine BioGeo region, had noticeably higher yearly averages, and they might have skewed the accuracy assessment results. Here, the residuals according to 22 DHMZ stations are presented, and it is clearly visible the distinction between residuals in the northern section of Croatia and the southern section of Croatia. The northern primarily consists of continental region, but not only this. If we take a look at the western part, Istria belongs to Mediterranean region, while the southern completely falls to the Mediterranean region. And from this figure, it can be observed that the largest residuals were resulted in this southern part of Croatia. So, not just due to 3 distinct BioGeo regions, but since larger residuals were resulted in the southern Croatia, and due to this 10-year discrepancy between CHELSA and DHMZ, this might indicate the possible effects of climate change. As I previously mentioned, this is primarily highlighted in May to September period in coastal DHMZ stations. However, there is a higher concentration of ground truth stations in the southern part. For example, in the eastern part of Croatia, there were only, I think, 3 or 4. So this uneven coverage likely impacted CHELSA validation procedures, which might be mitigated by establishing a local network of meteorological stations for some local studies which are primarily for agricultural or forestry related studies. In conclusion, there was an overall moderate accuracy of near surface wind speed monthly averages from CHELSA. Again, according to the available ground truth DHMZ climate stations. There was a high variability of accuracy metrics across the year, and a slight disagreement in terms of accuracy when observed from a relative standpoint, quantified by the coefficient of determination, and absolute matrices such as RMCA and normalized RMCA. This likely indicates a consistent bias, as I previously mentioned. So CHELSA values are either consistently higher or lower in all 12 months according to DHMZ ground truth data. Moreover, a notable distinction between residuals in northern Croatian region and southern, mostly Mediterranean coastal region was observed. This research was funded by the European Space Agency within the project Cropland Suitability Prediction Method for Land Management Planning based on Copernicus data for soybean, and it was supported by the Croatian Science Foundation for the ALCAR project, which is titled Assessment of the Long-Term Climatic and Anthropogenic Effects on the Spatial-Temporal Vegetated Land Surface Dynamics in Croatia using Earth observation data. Thank you very much for your attention.